Hi everyone, welcome to YourPedia. This is Chandrasekhar, faculty at YourPedia. This video is related to AAI ATC Physics questions. You all know that AAI ATC announced its examination date, that is on 14th of July 2025. So almost you are left with some 20 days around. So at this point of time, the very important thing is to practice the questions. How many questions you practice, that much benefit it is going to happen in your exam. Right, YourPedia started its module, Micromodule. What is a Micromodule? Micromodule is all about practice of questions. We started a module called Micromodule where we will be learning concepts and practicing a lot of questions in our Micromodule. Right, if you want to accelerate your preparation towards AAI ATC examination success, you can join our module, that is AAI ATC Micromodule. In this video, I am going to start with physics questions from the parts of alternating current and current electricity. See, in the micro module, you'll get a test series, you'll get practice questions, and you get live classes. These three are the benefits in the micro module: live classes with the mentor, test series, and practice questions. These three benefits you will get. And at this point of time, as I told you previously, how many more questions you solve, that much more benefit it is going to happen. Now let's enter into the questions. So almost some 20 to 30 questions I'll be solving in this class, right? So from the concept alternating current and current electricity, the first question is: in a circuit containing two resistors of resistance 2 ohms and 4 ohm are connected in parallel, then the total resistance is. Very simple question. Connection of parallel connection of resistances. If we connect, ignore the answer what is that is there here. Okay, I am doing here. See, if n resistances are connected in parallel, then its equivalent resistance is 1 by R equivalent is equal to, yes, 1 by R1 plus 1 by R2 plus and so on 1 by Rn. 1 by Rn. Here, how many resistances are there? There are two resistances. 1 by R equivalent is equal to 1 by 2 plus 1 by 4. The LCM will be 4. This is a 2 plus 1. This is 3 by 4. Then R equivalent will be simply 4 by 3 ohms. R equivalent is how much? 4 by 3 ohms. That will be nearly 1.333 ohms. 1.333 ohms. Option is C for Chennai. Right? Simple question. Sir, what happens if n resistances are in series? Exactly the summation. Means if resistors are in series, if n resistors, this is for parallel. This is for parallel. Okay. If n resistances are in series, now this is the yes formula. R equivalent is equal to, very simple. Here +2 physics, very simple. R1 plus R2 and so on Rn. Okay. So this is the formula for parallel combination of resistances, right? Let's go to the next question. Don't look at that solution. That solution is in the typed form, so that can be given to you, those who want that in the typed format, right? For them only that solution is there, right? Now, a battery of EMF 12 volts and internal resistance 2 ohm is connected to an external resistance of 4 ohms. He is saying that he is having a battery of 12 volts. Voltage of the battery is 12 volts, right? And it is having internal resistance of 2 ohms. This is battery resistance, please. This total is a battery, in fact, to speak. This total is a battery. This 2 ohms is the internal resistance of the battery, right? And it is connected to an external resistance of 4 ohms. Yes, this is connected to an external resistance of 4 ohms. The power dissipated in the external resistance is, our external resistance is how much? 4 ohms is the external resistance. So power in 4 ohms is, power formula is what? I square into R. That R is 4 ohms. What about I, sir? I is equal to V by R. V by R. Voltage is 12. Resistance is 2 plus 4, 6. So 12 divided by 6, that is equal to 2. Now put there P 4 ohms is equal to 2 square into 4. 4 4 is how much? 16 watts. How much it is? 16 watts. Yes, it is not there. Let me check any mistake we did in the calculation. Yes, 12 volts battery, fine, and internal resistance of 2 ohms. Okay, and it is connected to an external resistance of 4 ohms. Okay, 12, yes, 2 plus 4 is 6, yes, 12 divided by 6 is 2 amperes, 2 amperes, 2 square, I square into R, 2 square 4 into external resistance is 4 ohms. It is 16 watts only. In the option it is not there, it is 16 watts. We will take it as option B. We will take it as option B, please. Right? So here see, here the explanation is also wrong, it seems, but we are least bothered about the explanation that is there. See here, look at this explanation. Battery 12 volts, 12 volts, 2 ohms is the internal resistance, external is 4 ohms. Then current will be I is equal to V divided by R. 12 divided by 6 is 2 amperes. Very clear it is. So in this we want the power dissipated. I square is 2 square into R. 2 square is 4. 4 into 4 is 16. We are perfectly correct. No issues. Here what is saying? In a circuit, the potential difference between 2 points is 10 volts. If the electric field between these points is uniform and the distance between the points is 2 meters, then what is the magnitude of the electric field? It is a simple question. Electric field or electric field intensity is voltage divided by distance, and the units are volt per meters or centimeters. So depending upon the units what he given as it is, see here the options are not options are typed wrong. Volt per meter, it is volt per meter. This is volt per meter. Yes, this is also volt per meter. Yes, what is the voltage given by him? 10 volts. Distance is 2 meters. It is 5 volts per meter. 5 volts per meter. If he given in centimeter, you can convert the units. That's not an issue, right? Let's go to the next question. The drift velocity of electrons in a conductor is directly proportional to, you see that this is the drift velocity. See, drift velocity is directly proportional to the electric field. See, whenever electric field is applied, then electrons will get drift. Well, electrons will get drift. That drift of the electrons is directly proportional to the electric field. That is a theory question. It's a direct theory question that is directly proportional to the electric field. No more explanation is required for that. That is a simple question. Let's go to the next question. A 4 ohm resistor and 6 ohm resistor are connected in series with 12 volt battery. The current flowing through the circuit is, see, he is saying, yes, I will write here. Observe carefully, all of you. Forget about this explanation and answer. We do it very clearly. That is a 12 volt battery. There is a 12 volt battery. Yes, that is connected. Yes, a 4 ohm resistor and a 6 ohm resistor are connected in series. 4 ohm and 6 ohm are connected in series. 4 plus 6 is 10 ohms. Then I want current I is equal to V. My total resistance is 6 plus 4. So 12 divided by 10, this is simply 1.2 amperes. Answer also it is same, but here option is not given correctly. 1.2 amperes it is. Yes, 1.2 amperes. It's a typo. Option B is 1.2. It's not 1.5. Right? That is very simple question. I is equal to V by R. But these two resistance are in series. That's why we taken 6 plus 4 as 10. So V is 12. 12 divided by 10 is 1.2 amperes. That much simple it is. Let's go to the next question. Next question is from AC part. What is saying? In an AC circuit, if the current leads the voltage by 90 degrees, then the power factor is, what is power factor, please? What is power factor? Power factor, simply P dot F I am writing, is equal to cos of angle between voltage and current. What is saying? The current leads the voltage by 90 degrees. In fact, in which device current leads the voltage by 90? In capacitor, in ideal capacitor. So cos of 90 degrees, how much it is? 0. Yes, the power factor is 0. This is also called as zero leading. Why? Because current is leading. Zero leading, right? Very simple question it is. Direct answer it is. Direct answer, right? We are not looking at, do not look at this solution, please. This explanation we are least bothered. We have our own explanation. So this explanation is typed for the students who want this document, right? Yeah. In an AC voltage of 10 volts is applied to a resistor of 5 ohms. the root mean square current in the circuit is, he's asking about IRMS. So IRMS is equal to VRMS by resistance, that's all. What is VRMS? Voltage of 10 volts is said, voltage of 10 volts. An AC voltage of 10 volts is applied to a resistor of 5 ohms. Then the RMS value of the current is dash 10 divided by, if this is RMS value, yes, we treat, see, as I told you, always the given voltage we take it as RMS value. 10 volts is RMS value. See, in India, yes, this is the convention we follow. Suppose if I said 230 volts, 230 volts is the RMS value. Then what is the relationship between RMS value and maximum value? Maximum value is root 2 times of RMS value. Here 10 given by him. Yes, resistance of 5 ohms, resistance of 5 ohms. So 10 divided by 5 is 2 amperes. And I give here VRMS is equal to V maximum by root 2. This equally holds good for current also. Option is C. Here it is not B, it's a typo. Yes, option is C, 2 amperes. It is right. The next question, let's go to the next question, please. Yes, what is saying? The impedance of an RL series circuit is Z is equal to 5 ohms and the applied voltage is 10 volts. The current flowing through the circuit is, this is also very simple, that is I is equal to V by Z. I is equal to V by Z. So I is equal to, how much is the voltage given by him? 10. Current is, the impedance is 5. Impedance is 5, that is 2 amperes. This is only magnitude, please. This is only, all magnitudes only we are taking 2 amperes, it is, option is A, 2 amperes it is, right? So given voltage is always taken as RMS value, if he did not mention, right? Next, what is the next question? The frequency of an alternating current is 50 Hertz. What is the angular frequency? This is very simple question. Angular frequency omega is equal to 2 pi f, that is 2 pi into 50, and the units are radians per second. Angular frequency units are radians per second. So omega is equal to 100 pi. 100 into, yes, 3.14, almost it will be 314 radians per second. 314 radians per second. Here it is 100 pi. See, 2 pi f, here typo, here pi is missing, 100 pi. Option is B. Option is B, right? Typo, that B is missing, that pi is missing, right? Yeah. What is saying? In a series LCR circuit, the resonance condition is satisfied. Yes, we are least about this answer. What is a resonance condition? At resonance, first of all, let me draw series RLC circuit. R, this is L and this is C. This is R, this will be JXL, this will be minus JXC. Yes, this will be minus JXC. So this is the voltage V of T we apply. Yes, now Z is equal to R plus J XL minus XC. If XL is exactly equal to XC, then resonance occurs. Then what? Resonance occurs. XL is omega L, XC is 1 by omega C. This is the condition for the resonance. So option is A, omega L is equal to 1 by omega C. Now at the resonance, only resistance is left in your circuit. Now if this is the current I is equal to V by directly R at resonance, and the power factor is unity power factor, UPF, or power factor is 1, right? So these are the points about resonance. Let's go to the next question, please. The power factor of a purely inductive AC circuit is purely inductive for an ideal inductor. Yes, this is the voltage VL, this is the current IL, and this angle is 90 degrees. Now what is the power factor? I told you previously, power factor is cos of angle between voltage and current. Cos 90 is 0, but this is lag. Why? Current lags behind the voltage. Yes, option is A. We don't want this explanation, right? As I told you previously, we have our own very well structured explanation, right? That is also given by me, but there are some typos in it. That's why I'm asking you not to consider it, right? In a circuit with a total voltage of 100 volts, the current flowing through the 10 ohm resistance is, this is also direct question. Yes, I is equal to V divided by R, that is simply 10 amperes, simply 10 amperes. See, it is 10 amperes only, not 5 amperes. It is B for Bombay. I is equal to V by R. If it is AC or DC, for AC, the given voltage is RMS, the obtained current is also RMS. For DC, no RMS, no maximum, nothing. It's a constant value, right? It's a constant value. Yes, sir. Next question. Yeah. The total energy consumed in a circuit with an AC voltage of 120 volts and a current of 5 amperes over 2 hours is, it's a good question, energy is equal to power into time. Power is what? Voltage into current. Voltage into current into time. How much is the voltage? 120. Current is 5 amperes. But the time must be in terms of seconds. He asked 2 hours. He said it is 2 hours. 2 hours. Each hour is having 60 minutes. Each minute is having 60 seconds. Now, if you multiply this, you get. Our options are in watt hours. Options are in watt hours. So don't put this 60, 60, 120 into, see, 5 into 2 is 10, that is 1200 watt hours. Watt hours. See whether this option is there or not there. Option is there. If that option is not there, then go for joules. Joules and watt hours both are same, but hours must be expressed in terms of seconds. 1 hour is 60 into 60, 3600 seconds, right? So if you multiply with that, if that option is not there, that much big option not there. See, I am not taking 60 into 60 because 60 into 60 is 3600 into 10, 36,000 into 120, 3,60,000 into 12. It will be a big number. That much big number is not there in the options. And in the options, watt hour is mentioned, therefore don't write in terms of joules. You just check for watt hours. Yes, that is satisfied. How much it is? 1200. Right? Next question, please. Yeah. In a parallel combination of two capacitors C1, C2, the total capacitance is. In the parallel combination of capacitances, C equivalent is equal to C1 plus C2. It is exactly, the formula is exactly reverse to the resistances. Resistances in series, you can add this way, R1 plus R2. Capacitances in parallel, directly we can add. So this is capacitance in parallel. Capacitance in parallel. So if capacitance are in series, then 1 by C equivalent is equal to, yes, 1 by C equivalent is equal to 1 by C1 plus 1 by C2. This is in series if capacitances are in what? Series, right? C1 plus C2, 10 plus 20, how much it is? 30 microfarad, 30 microfarads. It is not A, it is B. Option is B, right? Option is B. See, capacitances in parallel, right? We are talking about capacitances in parallel. If capacitances in parallel directly added, C equivalent is equal to C1 plus C2. Next, the current flowing through a 100 ohm resistor when connected to a 200 volts DC sources. This is also direct question. Yes, I is equal to V divided by R, that is 2 amperes. Yes, answer is what? 2 amperes. See, in this phase I taken all simple questions. We are discussing simple questions. In the next phase we will discuss somewhat more depth than this part, right? Than this part. The directly Ohm's law, application of Ohm's law directly. Okay, next question. A battery of 12 volts EMF and internal resistance of 1 ohm is connected to a load resistance of 5 ohms. The power delivered to the load is here. It is similar to the first question, but the only thing it is changed here is this is minus plus, this is 12 volts. It is having 1 ohm and this is the load. 5 ohms is the load. 5 ohms is the load. So this one is saying it as load. Previously he asked about power dissipated in the 4 ohm, first question. Here load means there is a change in the nomenclature, that's why I taken it. Then tell me how much is the current. Current is equal to 12 divided by 6. How much it is? 2 amperes. Then power in the load. What is the load? 5 ohms is equal to I square. 2 square into 5. For 5 it is 20 watts. It is 20 watts. I think this also no option, but it is 20 watts. I square. I is 5 plus 1 6. Total current is 12 divided by 6 2. 2 square 4. 4 5 it is 20 watts. Yes, make it as option D as 20 watts. Our explanation is perfectly correct. It is option D. Yes, it is 20 watts, right? It is 20 watts. Here also the same is there, but options are, I think, clubbed here and there. Options. Don't see the options, but the explanation is perfect. You can see here, right? Yeah. The time period of an alternating current is 20 milliseconds, then what is the frequency? He given time is equal to 20 milliseconds of a full cycle. Then what is F? F is equal to 1 by T, then 1 by 20 milli means 10 to the power of minus 3. 1000 divided by 20, it is simply 50 hertz. Option is what? 50 hertz. Option is B. Option is B, right? Next, a 60 hertz AC supply is connected to a coil. The coil has an inductance of 0.2 Henry. The inductive reactance is, good question, inductive reactance XL is equal to 2 pi FL. So XL is equal to 2 pi into frequency is what? 60 into inductance is what? 0.2. Then how much it is? 6 into 2, 12, 24 pi. 24 pi it is. 24 into pi is 3.14. Without calculator you have to check its nearby value. It's nearby value. 24 3s 24 into 3, very simply 60 plus 12, around 72 or 73 or 70 above, 70 above. So nearest option is B. Here it is not A, it is B. Nearest option is B, B for Bombay, right? Yeah, ours is perfectly correct. Without calculator you must be in a position to multiply at least to the nearby and you must choose the correct option. It's not going to be 37, it's not that low. It's not going to be 18, it is not that low. 94, it is exceeding, right? It is 75 only. Yes sir. 2 pi FL, 2 pi. In fact, one more thing I forgot. Yeah, 2, how much is 60 into 0.2, 12. 12 into 2, 24. Yes, 24 into pi is 3.14. Here, yes, it is correct only. Here, this is a nearby 74 change. 74 change. You can check the multiplication once. You can check the multiplication once, right? Yeah. In a simple AC circuit, the phase difference between current and voltage is 90 degrees. What type of load connected? Yes, as we discussed in the previous problems, for an ideal capacitor, current leads the voltage by 90. For ideal inductor, current lags the voltage by 90. Yeah, this question is from the previous problems concept. Yes, very first, I think in the very beginning of second or third problem, I didn't remember, there he given, he's asking about power factor. I told you their power factor is 0 leading. Why? Because in a capacitor, current leads the voltage by exactly 90. In an ideal inductor or pure inductor, current lags. It may be purely inductive, it may be purely capacitive. Why? Because he's saying that phase difference is 90. Phase difference is 90. He is not saying that phase difference is 90 lead or 90 lag. If it is 90 lead, capacitive, if it is 90 lag, inductive. So combination, see, the option D is option, let's take it as option D. Option D is either L or C. It may be L or C. It may be L or C. For a purely inductive load, the phase the phase difference is 90 degrees, and pure capacitive load also, pure capacitive load also, yes, phase difference is how much? 90 degrees for pure capacitive load also, right? Next question. Yeah, in a series RL circuit, the voltage across the resistor is 10 volts and the voltage across the inductor is 20 volts. Then what is the total voltage? Very good question, right? Observe here. See, most of the questions are easy questions I taken, but this is very easy question. This is R, this is L, yes, but this is JXL. This is how much? 10 volts. This is 20 volts. It is not the arithmetic combination. If I draw the phasor diagram, this is the current I, this will be voltage across resistor, this will be voltage across inductor, then this will be the total voltage V. V is equal to root of VR square plus VL square. It is parallelogram law of addition, but not arithmetic addition. Root of 100 plus 400, 20 square is 400. This is root of 500. So that will be 10 into root 5. 10 into root 5. Yes, 10 into root 5 nearly. 10 into root 5 nearly. So exact option is not there. Root 5 will be, I can say root 4 is 2 point something. 2 point something into 10, nearby 20 you get. None of the option is correct. None of the option is correct. I can say answer V is equal to 10 into root 5. 10 into root 5 volts. Right? See, in this class I taken all simple questions so that you can understand. In the next video I'll be taking more or above level of AAI ATC. This kind of questions, very simple questions, were asked previously in the AAI ATC examination. That's why I taken simple questions only in the first phase. In the next phase I will be taking some moderate to difficult questions, right? All the best.